Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called An Exercise in Coloring by Dr. Logic. And since I love coloring, that's one of the, that's a large reason why I chose this puzzle, because I love coloring in Sudoku. Anyways, let's get to the rules. We have normal 8x8 Sudoku rules apply, which means place the digits 1 through 8 once each in every row, column, and marked region. So this is irregular region Sudoku. And actually, it would be normally, I guess that's the case with normal Sudoku too. This irregular region Sudoku is essentially the same thing. It's just here it's digits 1 through 8 instead of 1 through 9. And the regions are not boxes, but they are 8-cell regions. We also have adjacent cells along a green German whisper line differ by at least 5. So, for example, if we had a 7 here, these digits would have to be 1 and 2, because the only digits which are 5 or more away from 7 are specifically 1 and 2. And I will be calling them Whisper 5 lines because a setter came up with that naming convention, and I thought it made a lot of sense because it's very easily extensible. Digits along the arrow sum to the digit in the attached circle. So, for example, if this were, say, 1, 2, and 4, this would have to be 7, because the digits along the arrow must add up to the digit in the attached circle. We have normal thermometer rules, where digits increase in size from the bulb end. So this must be increasing from this cell to that cell, and this cell to that cell. So you could have something like 3 to 4, and 3 to 8. And those would be both valid because you're increasing from the bulb to the tip on the thermometers. Cells separated by a black dot are in a 1 to 2 ratio, and not all such dots are given. So this is in a 1 to 2 ratio, so actually we can't make that 7. But if we made that a 2 here, then this would have to be 1 or 4 to maintain the 1 to 2 ratio that's between them because there's a black dot there. Cells along a pink Renban line form a string of consecutive numbers in any order. So, for example, you could have something like, say, 4, 6, and 5 here, and that would be valid because 4, 5, and 6 is a valid, they form a set of consecutive digits, or a string of consecutive digits. What you could not have, though, is something like 4, 6, 7, because 4, 6, 7 does not form a set of consecutive digits, right? You have a jump between 4 and 6. Excuse me. And then 7 on the Renban line. And finally, digits that see each other by a knight or king's move in chess cannot be the same. So whatever digit, so if say this was a digit 6 here, it could not, in addition to not being, there can't be any repeats in any row or column or region, you also cannot have repeats in any of the cells that would be a king's move away, which are the eight cells that touch that cell, whether on a corner or on an edge, and then anything that's a knight's move away, which would be 2 in one direction and 1 perpendicular from there. So these would all be considered knight's move away from this cell. And you can't have repeats, so this cell could not be here by normal Sudoku. Or not normal Sudoku, by anti-knight and anti-king rule set. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so this digit cannot be the same as these digits in this box by normal Sudoku rules, Can't be here because of anti-king, can't be here because of anti-knight. So this digit must be the same as this digit. And so it's the same for all of these regions here. This digit is a sum of 3 unique digits. So it has to be at least 1, 2, and 3. So this is 6, 7, or 8 here. These are in a 1 to 2 ratio here. So it's either 1, 2, 2, 4, 3, 6, or 4, 8. We don't know. So this digit must be the same as that. So we'll mark that as blue and blue. This digit must be the same as that one. So we'll mark that as orange and orange. This is the same as that. It's green and green. And this must be the same as that. So we'll mark those as red. Well, obviously, these have to be different digits because they are a king's move apart from each other. So they must be 4 unique digits here. So green, where can green be in row 3? Obviously can't be here because they're in the same region. Can't be here by king's move. Can't be here by knight's move. Actually, where is green in row 1? Can't be here because of green already in the box or in the region. So it has to be one of these 4, which means we cannot have a green in the rest of this upper right-hand region. So where's green then in row 3? Can't be here because of greens in the region. Can't be here because one of these 4 must be green in the region. So it has to be, can't be here because of anti-king. Can't be here because of anti-knight. So green has to be that cell there, which means green in row 1 cannot be any of these 3 cells because it has to be, this is by normal Sudoku, this is by anti-knight, this cell sees all 3 of these cells. So green has to be that cell there. So similarly in column 8, where's the green? Cannot be here because of green in the region, so green has to be here, which means we can't have a green anywhere else in this region. Green in column 6 can't be here because of anti-knight, so green has to be one of these 2. Similarly for column 1, green is one of these 4 cells. Green can't be here and here, can't be in this region. Can't be here because of anti-king, can't be here because of anti-knight. So green has to be here, which means this can't be green. So that means this is green there. This green eliminates green as possibilities here by anti-king, by normal Sudoku and anti-knight. So therefore green has to be there. Which leaves green remaining in column 8 as there. So we should be able to deduce this information too. And this is why this is an exercise in coloring. Orange. Where can orange be in row 1? It's one of these 4. That means this can't be orange. Anti-king, anti-knight eliminates orange there, so this is orange there. No orange here by anti-knight in normal Sudoku, so orange is there. Orange has to be one of these 3, actually. No anti-king, normal Sudoku by one of these 3 oranges, and therefore orange is here. Cannot be anti-king, and this is green. So that means orange cannot be any of these, so orange has to be here. This can't be orange because of we have orange guaranteed one of these 3. Can't be here, so it's one of these 2. Orange can't be here because of the orange in the region. Can't be here, so orange is there. Which means orange has to be there. So let's do the same for reds. Again, red has to be one of these 4. Red cannot be here then in column 3. No anti-knight, anti-king, so red is here, which means that sees all of those 3 cells, so this one must be red. Red has to be one of these three, so therefore cannot be here. Anti-king means this is red there. Anti-knight and normal Sudoku eliminates these three for red, so this is red here. Okay. That leaves one of these as red here. That leaves red being there and red being there. So this is probably going to be the same. So then we have to have blue. Blue has to be one of these three. Cannot be here then. Can't be here by his anti-king. So this is blue there, which makes that blue there because of anti-knight and normal Sudoku. Blue has to be one of these four. Can't be here then. Can't be here because of anti-king, so blue is there. Anti-knight and normal Sudoku makes that blue then. That forces this to be blue and blue, I believe. Right, one of these is blue. This can't be blue because of anti-knight. This can't be blue because of one of these is blue, so therefore, yeah, we have that information. Okay. So here we have orange between... So orange has to be 5 or more away from red. Green must be 5 or more away from blue. So green has to be a low because blue is guaranteed to be 6, 7, or 8. Green is... So green has to be a low. And it cannot be 4. So green has to be 1, 2, or 3. To be 5 or more away from blue. So therefore this cannot be 1, 2, 3, because if this is 1, 2, 3, that would eliminate all possibilities for green here. So this cannot be 6. So 1, 2, or 3. 1 can be with 2. 2 can be with 1. 2 can be with 1 or 4. But 4 is not going to be 5 or more away from a digit from 1 through 8, right? In normal Sudoku, it can only be 5 away from 9, but we don't have 9 available, so this can't be 4. So this is 1 or 2 here, or it's 6. We're not sure. If orange were here, though, as 1 and 2, the problem is it would have to be 1, 2, 3 for this Renban, if it were 1 or 2. Or 2, 3, I guess it could be 2, 3, 4. So orange can never be 1, because if orange is 1, that means this is 1, it would have to be 2 and 3 here, but that would eliminate all possibilities for this green cell. So orange cannot be 1, which means green cannot be 2. So green has to be 1 or 3. But if green were 1, the remaining digits here have to be at minimum 2, 3, and 4, which add up to 9, which is too large for this 8 by 8 normal Sudoku. So this cannot be 1. So that forces this to be... So all the greens are 3. All the oranges are 6. 3 can only be 5 or more away from 8, so therefore the blue is 8. Oranges have to be 5 or more away from red, so those must be 1. And the remaining digits have to be 1, 2, and 5 to add up to 8. So we have 3 here. This is a Renban here. So it guarantees has 4 on it, because you cannot have 1, because of 1 already in the region. So it's either 2, 3, 4 or 3, 4, 5. Either way, it guarantees has a 4. This 6 cannot have 8, so it has to have 5 on it, because it's either 5, 6, 7 or 4, 5, 6. So we have 5 here and 5 here. Remaining digits here are 2 and 5, which eliminates 2 and 5 in the rest of the region. Therefore, this is 4 and 7. Which eliminates 4 and 7 in the rest of the column. So this must be 5 and 2. 5 has to be on this red band. So this must be 5 here, which makes that 2 there. No 5 or 2 here. This is 4 and 7, which eliminates 4 and 7 in the rest of the row. That leaves this as 2 and 5 as a pair. 4 has to be on this red band, so 4 is there. That leaves this as a 7 there. Remaining digits here are 2 and 5. So we have 2 and 5 here, 4 and 7 there. The remaining digits here in row 2 are 4 and 5. This digit is a king's move away from this digit here, and a knight's move away from that digit there. So this cannot be 5 because one of these two is a 5. And it would be either a king's move or a knight's move away. So this is 4, which makes that 5. 4 eliminates 4 from being here by anti-knight, so that's 7, which makes that 4. 4 can't be here, 4 can't be here, so 4 has to be here in this region. Where's 4 in this region? Can't be here because 4 is in the column. Can't be here because of anti-knight, so this must be 4 here, which makes this 7, which makes that 4. This is 2 or... Hold up. Oh yeah, this 2 or 5. This is 2 or 5 here. So this cannot be the same as that. Okay, so we can remove all the coloring here. So we'll make this blue and we'll make this yellow. This is anti-knights away from that. So this cannot be yellow, which makes that blue, which makes this yellow, which makes that blue. Where's blue in this region here? Can't be here, can't be here, so it must be here. And this sees this cell by anti-king and this cell by anti-knight. And it cannot be, these are remaining digits are 2 and 7. 7 eliminates 7 here by anti-knight, so that's 2, which makes this 7. 5 eliminates 5 here, so that's 2, which makes that 5. This can't be 2 or 2, but we know it has to be 2 or 5, so it must be 5 here, which means yellow has to be 2. Whereas 2 in this region here can't be here because of 2 in the column, so 2's there. That eliminates 2 from being there, so 2 has to be there. So no 2 here, no 2 here, which leaves 2 as there. 4 is anti-knight, eliminates 4 there, so that's 7 and 4, which leaves that as 7. 5 can't be here because of 5 in the row, so 5 must be there. That leaves that as 7. This is 4, and this is 7. And that's how you solve it. Actually pretty cool, nice use of coloring and these irregular regions with the anti-knights and anti-kings to force a certain situation. Yeah, I mean, just overall pretty nice little puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.